Hello, welcome. Today let's try to solve another Leetcode problem. 1976, number of ways to arrive at destination. So we are just giving a graph structure. So this road means from node U to node V with a cost of 7. So this 7 means time. And this n is the total number of nodes. We just need to calculate how many sorted paths from the node 0 to node n minus 1. So for this example, from node 0 to node 6, how many sorted paths? So we can find there are 4 sorted paths. Yeah, we need to calculate how many of them. And the result should be modular to 10 to the power of 9 plus 7. So this means, yeah, we cannot count the paths one by one. We have to use some memories to record the path. Yeah, let me first explain it in the whiteboard and then go to the code editor to finish the coding. For this problem, we're gonna use the Dijkstra sorted path to solve it. So for example, if we have some node, so this is like node 0, maybe go to node 1, 2, 3, and there would be another node. For example, this is node 4. And yeah, we wanted to calculate from node 0 to node 4 what is the sorted path and how many of them. So for example, this is just 1, 1, 1. This is just 2, 2, 2. Yeah. For simplicity, we want to calculate the distance from 0 to 4 and how many of them. So the sorted path is 3, and how many of them, as we can count it, it is like this is 1, this is 2, and this is 3. So in total, there are 3 paths. But inside the Dijkstra programming, yeah, inside the algorithm, how should we calculate it? So this is from the beginning. While we go to this node 1, we're gonna have a record. So we're gonna record of ways, or we can get, yeah, we can have a record of ways. So for while 0 to this node 1, so there's only one way, and 0 to this node 2, so the sorted path, there's still one way, and while it goes to node 3, it is still one way. Yeah, because for 0 to 3, what is the sorted path? It is 1, and how many ways? It is only 1. Yeah, and similar for others. Now we will go to node 4. So while we go to node 4, so from node 1, we can go directly to node 4 with a distance with a time of 2. So the total time will be 3. And how many ways? So it will be this value 1. Yeah, it should be equal to this value, no matter what its value is. Currently it is 1. It can be 5 or 6, but currently we're gonna count it as 1. Yeah, and with a distance of 3. Now, while we are checking this node 2 from 0 to 2 to 4, the sorted path is still 3. Yeah, so that means we will not update it. We're gonna count it. Yeah, it is 3. We're gonna count it another one. So from node 2, there's another one. So 1 plus 1. Currently it is 2. Now we are checking this node 3. So for this 3, there is a number of ways. How many ways? It is 1. And with a distance 1 plus 2, it is still 3. So we're gonna count it plus another one. So it's gonna be 3. So this is gonna be the result. Yeah. So for example, if this is distance is 1, what are we gonna do? Because this is 3 and the right side is also 3, but in the middle it is 2, so we're gonna update it. Yeah. While we updated it, we're gonna use this one, and we're gonna record only this one because this is the sorter, so we're gonna count it only as 1. So everything here and here is inside the Dijkstra algorithm. We're gonna calculate just yeah, inside the algorithm. We do not need to calculate another time. We just calculate inside the algorithm. Yeah. Now let's just go to the code editor to finish the coding. Yeah, let me first prepare a graph because I'm gonna use it later. So it's gonna be a default dict. Inside it's gonna be list. Now I'm gonna prepare the graph. So for UVT inside the load, because it is undirected, so I'm gonna prepare an undirected graph. So it's gonna be gu.append. Inside it's gonna be v with this time, and similarly gv should dot append. It should be u and t. So this is the preparation for the graph. Now I'm gonna prepare the Dijkstra array. So the Dijkstra array will be infinite times n. Yeah, I also need to prepare another array. I'm gonna prepare it as paths. How many paths? Yeah, so the path array is gonna be starting from 0 times n. Basically, this path array is to calculate how many paths from node 0 to node n minus 1. So for the node n minus 1, we just need to return the path minus 1. It's the final result. Now, for the Dijkstra 0 and path 0, we can initiate the values. The Dijkstra 0, as we know in Dijkstra's algorithm, the Dijkstra 0 should be starting from should be 0. Because the distance, the cost from the first node is gonna always be 0. Yeah, because we didn't go. If we go from 0 to 4, it have a cost of 5. But at the moment, we're gonna prepare the Dijkstra 0 to 0. But for the path 0, because we're gonna use it to calculate, yeah, we're gonna prepare it as 1. Otherwise, it's gonna never increase. So this is the path array. Now I'm going to prepare a PQ. So this is the priority queue. Inside, it's gonna be the time. For the first node, from the beginning, the time is 0 and the node is 0. So inside it is the time and the node. Now I'm going to check the priority queue. While PQ, I'm gonna pop out. Yeah, while PQ exists, I'm gonna pop out the time and the node U should be hip pop with this PQ. Now I'm going to check its neighbors. So for V, because inside of the neighbors, it can be V and time. Yeah. So for here, I'm gonna use another variable C as the new time. It's also a cost. Yeah. So for VC in GU in this node. Yeah. So my new time would be this T plus this C. So this is the Dijkstra's algorithm because we need this kind of T. So this means from some node to this node U, and then from some node U, from node U to node V, it has a cost of C. It has a time of C. So this T plus C, basically we need to check this time. So if this time is less than the distance array, inside it's gonna be the V, its neighboring node. Yeah, if it is less than that, so we can update the distance array. So the dist V should be equal to the time. And we can also update the width. So the width of V should be equal to it's coming from where it's coming from. It's coming from the node U. So it's equal to width U. I'm not gonna use the width. I'm gonna use the path. So let me copy the path. Yeah. Now we need to put something inside the priority queue. We're gonna use the heap pulse. Yeah. So the heap pulse should be a priority queue with the new time and the new node. It should be node V. Yeah. And there's also another case. So if the time equal to the distance of this V, yeah. So this means there's another node if it is equal. So for this node, if it is less than, and then let me go back to the drawing. Yeah, it means, for example, for this node 1, we find a distance if this is 2, And if we find another one, it is equal, yeah, in the middle. And at this side, there's another one, it is equal. We're gonna plus it. So here, this path should plus the path. So here, the pathway should plus the path U, where it's coming from. And finally, we just need to return the path with -1 because -1 is to this last node. Yeah, basically this is the entire code. You can say that is not so easy. That is not so difficult. I mean, if you know the Dijkstra's algorithm and you can write the Dijkstra's algorithm. So the hard part is about this area. How should you check the path? And here, also here. Yeah, just increase the 1 line of code and another 2 lines of code, and you can calculate the result. But this is gonna be hard. You have to, yeah, totally understand what's the meaning of Dijkstra's algorithm. Yeah, it's similar like the dynamic programming. Yeah, you have a record of the previous path. So the path, this path array is just a record of the previous ways. So for example, for this node 4, how many ways to this node 4? How many ways to this node 3? And how many ways to this node 5? And finally, we just need to calculate. Yeah, if it is equal, we're gonna accumulate. And we can accumulate from here. If it is not equal, so we're gonna update a new value. We're gonna put it inside the priority queue. And finally, we just need to return the final result. Now let me just run it. Oh, here is something wrong. Let me check. Yeah, let me delete these areas. Yeah, there's still something wrong. Let me check the last one. So this means I didn't use the modular. Yeah, basically I also need to prepare a modular. This is given by the question. It is 10 to the power of 9 plus 7. And finally, we need to modular this mod. Now let me just run it to check again. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. Basically, it is just like 20 lines of code, and most of the code is a Dijkstra's template. We just need to analyze how to calculate the path, how to calculate the ways. And now let's analyze the time complexity. So for the time complexity, we're gonna use the number of the node. It is 200. Yeah. So I will not analyze these areas because these areas will not increase the time complexity for Dijkstra's algorithm. Basically, for the Dijkstra's algorithm, it is it is E log V. It is E log V. E is the number of edges. Why? Because for here, for this for here, we're gonna check how many edges. So for this way, it is connected to U, and we basically check how many edges. And for the heap push, we're gonna check, how many vertices. So the time complexity for the heap push, it's gonna be log V. And here, for this for loop, it's gonna be E. So the time complexity will be E log V. So for E, it is n squared. So it is n squared times log n. So that is for the final time complexity. If you think this is helpful, please like and subscribe. See you next time.